What's that?
Are you still using high school geometry for this problem?
Yes.
Is that AP high school geometry?
What's an AP high school geometry?
I don't know.
Never heard of that. Never heard of that.
Shoot, you guys, I'm getting myself in a bit of trouble. I think. I'm too tired. What do you think? It looks like a semicircle. Graph it, let's graph it. So graphing it, if x is equal to 0, the corresponding y value is,
A problem.
yeah, a problem. I'm being too clunky doing this. I think it's a better way to graph. What about completing the square?
Yes.
You guys remember that, don't you?
Yes.
Is someone completing the square? Does that give me a? Actually, I can't complete the square yet. You guys, it's too sloppy. Can I just co-locate the expressions and slough off the constant? So, you guys, since you are indeed math D experts, help me with this. The square of half the coefficient of x is no, it's a mistake because you have to first
Oh, wait for it to
get rid of the negative sign. I gotta force that leading coefficient to be 1. So if you guys don't mind, since I'm concentrating on the first two terms, let me just pull out a common factor of -1. Okay, no tricks. I think I just set myself up for completing the square, at least inside that set of parentheses. And therefore, I think I'm left with the integral from 1 to 3 of the square root of a negative x squared minus 4x, stop, leave myself a bit of room, minus my 3. Oh, you guys, I'm getting tired of hearing my voice.
Well, plus 4. Plus 4.
Nice. And I think that leaves me with the integral from 1 to 3 of the square root of 1 minus this perfect binomial square.
Plus 1. Oh, you're right.
And if I asked you guys to consider this equation, can we just clean it up? How about getting rid of the square root by squaring both sides? And then maybe
Subtracting 1?
how about adding the binomial square root of both sides? But shoot, you guys, that means I've got a circle whose center is located at 2, 0. And whose radius is going to be positive 1. You guys have got all got quiet. Are you saying I made a mistake? Yeah, I think I am making a mistake. You know, technically speaking, you guys, when I squared both sides, I lost track of the fact that y was only positive. So I do think, necessarily, that's not my picture. I think I just got a semicircle above the x-axis from 1 to 3, and now to divide this integral. Are you ready to use some calculus?
No.
No, I'm not either. I think we can just use a high school geometry. What's the area of any circle? Pi squared. So the area of that circle I initially had drawn is to be pi times 1 squared, which is just pi. Oh shoot, I messed up. I've only got a semicircle, so I guess the answer is
Pi squared divided by 2.
pi hands. Now isn't that a piece of cake? No, it's a piece of pie. But you guys see my point to that. Some of these integrals, I really can't just rely on basic high school knowledge to know these math. As long as you can translate this particular integral into something that's more familiar to you in terms of basic limits. Are you there? Okay.
I'm scared.
Now you're scared.
Refresh.
Do you guys think I can finish up tonight just by giving you, slightly justifying some basic properties of integrals? Like, for example, here's one basic property of integrals. If you were to integrate from A to B, some constant times some function of added x with respect to x? I want a yes or no answer. Does it seem like this really should be c times the integral from a to b of f of x dx? Yes? What can you say so fast?
Just
You
pull
said it
out
was
the
a
constant.
It's just a constant.
But I thought these symbols were new to us tonight. How can you be so fast?
Because it doesn't matter, it's just a constant. You can pull the constants out of the integrals.
Pull the constants out of the...
Integrals?
Yeah, but they're new to me. So pull the constants out of the...
The squiggly line.
How about limits? Because I think, when it comes to this particular integral, if I use my right endpoint rule, isn't this nothing more than the limit as n increases without bound of the sum of the c times f of x of I bar delta epsilon as I range from 1 to n? Do you guys agree? Oh, but shoot. These constants we already saw get pulled out of the summation notation. That was just distributive property multiplication over addition on a part larger scale. And then we already know that the constants get pulled out of limit notation. I think this is just c times the limit as n places came of the sum as I place its game of my f of x of I bar times my delta x of I. Ah, but shoot, that's nothing more than the integral from a to b. So I think it comes down to what you and I know about sums and what we know about limits. I think using exactly the same logic, I can make the proclamation that if I were to take a peek at the integral from a to b of the sum of f of x and g of x with respect to x, using the same logic, using the same definition, I think I can reinterpret this as the sum of two integrals from a to b of my f of x and my g of x, respectively. What happened here? You guys, if this were a regular partition, and I choose the right endpoint rule, wouldn't I get this? Where delta x is just
B minus A over N.
yeah. And so I think that's the same as this. And that's the same as this.
Why did you switch the B minus A?
Are you saying I can't?
Where's your negative sign?
Thank you. I guess I can't. I guess subtraction as an operation in the real number system does not commute. If I'm going to interchange these two terms, what have I really done?
Almost
It's
one.
not negative one.
I have. I'll compensate. I messed up. I'll fix my mistake. Bottom line is that from now on, if you guys have an integral, you do not like the order of the bounds of integration from A to B, and you want to swap them, go for it. You can do whatever you darn well please. It's just when you swap them, I change my sign. You guys, again, this isn't physics. I don't want to come in and talk about laws. I want to talk about properties of integrals, and I can justify everything I'm saying. Actually, I need to stall you guys. Missing.
Plus C.
You know, I don't have to put in plus c because it's a definite integral. Besides that, I didn't actually integrate both either side, so I'm not dealing with the c's. You guys, I am missing something. Part 4. How about this? What do you think you can say about the integral? Here.
Is that a 9?
No.
A.
So A to A.
One.
If you're not evaluating any width area.
There's no width. You know, that's a good way of looking at it. I wasn't even thinking of it. So you're saying, well, from the interval from A to A, there is no width, so there's no real area underneath the curve. I was thinking this. I was thinking, going back to my
Just be A?
definition, if B is A, the horizontal width of each of the sub-interval is going to be 0. So adding a bunch of things, each of which has a factor of 0, is going to be 0 itself. We're there. You know, maybe I should talk about this more next time, because I want to draw some pretty pictures, but it is the case that if you got the integral from A to B, for that, you can rewrite this as the integral from A to, how about anything else you care about, please?
From C to B then?
Plus the integral from C to B. Now, I guess the way I'm writing this, I'm proposing, I'm suggesting that C lives somewhere between A and B, but it doesn't have to be the case. And I'll draw some pretty pictures to justify it next time. Questions so far? You guys willing to get some practice? So a little bit of practice? Just a little. I haven't done much tonight. Just a little.
Let's do it.
One problem is 2-page width. Just a couple.
So I need to go back, take a few things up from 5.1, like these. So everybody's got their food put away. You have nothing to throw at me, right? Right. You guys don't have anything going on. That's good to you.
Just all our other classes.
Oh, come on, you don't have a life.
I don't have a life.
Because of
Touche, touche.
Is that a 55 then or 59 on top?
It's
59. Oh, thank you. Oh, as usual, guys, let me know how it goes. You know I'm going to be around the math center. So.
Math center all day tomorrow.
Just think about it, you guys. By this time next week, we'll be done. Well, we'll get home.
Yeah, for like 2 weeks. Let's see, 65.
My
Jeez.
family doesn't know me because of calculus.
So you're saying all these questions are like 2 pages long?
Yeah.
Oh, man.
I don't know who I am anymore.
Identity crisis.